refractive index and what is relative refractive index. Let's consider two cases. Suppose there is a boundary and light enter from air or vacuum to another medium, let's say some medium. If light enter from here and enter into this medium, what happens here? If velocity of light is c, or sometimes we call it cv, velocity of light in vacuum, and in this medium velocity of light, let us say cm, because when light travels from one medium to another medium, its velocity changes. So its velocity in vacuum is cv, velocity in that medium is cm. Then refractive index of this medium with respect to air or vacuum, we consider this air or vacuum because velocity of light is the fastest in air or vacuum, which is 3 into 10 power 8 meter per second. So here refractive index of this medium mu m is defined as velocity of light in vacuum divided by velocity of light in medium. Sometimes cv we call it as c divided by cm, both actually 3 into 10 power 8 meter per second, that's it. Suppose light travel from medium 1, let us say this is medium 1, and it travel into another medium 2. Then here the refractive index of medium 2 with respect to refractive index of medium 1 is defined as refractive index of the 2 or the second medium with respect to the first medium. Generally light travels from 1 to 2. In that case, it is defined as velocity of light in medium 1 divided by velocity of light in medium 2. Here what I am going to do is I'll just multiply and divide by velocity of light in vacuum. So I can write this CV up here and I can bring this here. So this C2 can be written as 1 by C2 and this C1 can be written as 1 by C1, because 1 by 1 divided by 1 by C1, this goes up and this comes down. And then this CV, I'm going to write it here into CV by CV. So this can be written as CV divided by C2 divided by CV divided by C1. So refractive index of the second medium with respect to first medium is CV by C2 divided by CV by C1. But look here, if I want refractive index of the medium, velocity of light in vacuum by velocity of light in medium. Suppose I have medium 1. What is refractive index of medium 1? Velocity of light in vacuum by velocity of light in medium 1. So this is the absolute refractive index of medium 1 that is defined with respect to vacuum. What is absolute refractive index of medium 2? It is velocity of light in vacuum by velocity of light in medium 2. Then what about refractive index of medium 2 with respect to medium? Means this is relative refractive index of 2 with respect to 1. This is called relative refractive index of medium 2 with respect to medium 1. This is also called refractive index of 2 with respect to 1. This is CV by C2 is mu 2 divided by CV by C1 is mu 1 as from this. So let us say absolute refractive index of glass is velocity of light in vacuum by velocity of light in glass. Absolute refractive index of water is velocity of light in vacuum by velocity of light in water. So refractive index of glass with respect to water, this is called refractive index of glass with respect to water, that is equal to, based on this formula, mu 2 1 equal to mu 2 by mu 1. Hence mu GW means refractive index of glass with respect to water, which is refractive index of glass divided by refractive index of water. This is 1. Suppose if they ask what is refractive index of water with respect to glass, so refractive index of water by refractive index of glass. So this is how we define absolute and relative refractive indices. Again I am telling, so remember this, refractive index of 2 with respect to 1 means refractive index of 2 by refractive index of 1. What is refractive index of 1? Medium 1, it is velocity of light in vacuum by velocity of light in medium 1. What is refractive index of 2? Velocity of light in vacuum by velocity of light in medium 2.